Assalamualaikum warahmatullahi wabarakatuh, and good day to Prof. Dr. Naraza Yusuf and also my friends. We are from Group 7. We got topic about acid rain. So before we going through, I want to introduce our team. And first one is me, Muhammad Nuruddin bin Ruslan. My matrix number is 207 And then I student Aziz bin Shazlan, Muhammad Iman bin Abdul Basir, and also Muhammad Ikhwan bin Muhammad Shafi'i. Sorry. So for the introduction, a student is formed when acid reacts with sulfur dioxide also. I'm sorry. Acid is formed when chemicals such as sulfur dioxide or also nitrogen oxide react with water in atmosphere. Therefore, it will produce a mild or we call a low concentration of sulfuric or nitric acid. And then the terms it also includes when some form of precipitation with acidic components such as sulfuric or nitric acid is fall on the ground. For example, we know that such as snow, also fog that is a little bit acidic. So there are some causes or some factors of acid rain. So the first one is about natural causes. So natural causes is from uh, natural occurrences such as volcanoes that release the gases, the unwanted gases. So it will increase the acidity of the rain, and also we can take to account other natural occurrences such as lightning strike and also wildfires. And then the second factors of acid rain is electricity generation. We know that after the industrial revolution, the consumption of the electricity are getting higher and higher year by year. Therefore, the the coal combustion from the factory in order to produce electricity rise up. Therefore, the amount of sulfur that enter to atmosphere and also air are increasing. The next part is the next part of causes of acid rain is from the vehicles. So we know that uh, amount of vehicles also release the unwanted gas that releases the unwanted gas such that I'm sorry, the vehicles will release the unwanted gas that lead to acid rain issues. And then the last part of the causes of acid rain is in agriculture. So this is because farmer use exceeded farmer use exceed amount of fertilizer in order to increase their crop yield. The fertilizer also contains nitrogen and also unwanted element or compound. So this will lead to acid rain. So that's all for my part. We will continue to the other part with my team.
So now we have already looked into how the acid rain happened and also the chemical reaction involved and product formed from it. So now let's look into the solutions on how to stop acid rain. So the first solution is actually reducing fossil fuel usage. As we all know, fossil fuel will undergo combustion and will release sulfur dioxide as well as nitrogen oxides in the atmosphere, which in turn cause acid rain. And the example of fossil fuel is diesel, petroleum, coal, and a lot of it. So what we as responsible consumers can do is walk. If possible, if the destination is very, very near, it is best to just walk our destination as we can cut off sulfur emission completely. But if we do not have a choice, we can actually do carpool because by carpooling, we are actually able to cut to at least half of the sulfur dioxide and nitrogen oxides in the atmosphere. And the third choice is actually to use public transportation. And it is much greener to use alternative transportation, which is public transportation, than normal vehicles. Why? Because they produce much, much less sulfur dioxide as well as carbon dioxide in the atmosphere. So, statistics in London alone shows that the city releases about 22% of global emissions for transportation, but only 0.8% comes from their train system. So this is actually much, much more safer and much less pollution created by the transportation. So most vehicles like our cars, lorries and buses releases nitrogen oxides of nitrogen as well as sulfur dioxides from their engines, as you can see here. Here. So when it releases, also factories also releases nitrogen oxides of nitrogen as well as sulfur dioxide as well to the atmosphere. So when the sulfur dioxide is exposed to the air, it will react with oxygen to produce two sulfur trioxide, and then the sulfur trioxide will react with water in the air to produce sulfuric acid, which is the acid rain, which will go down to the earth when it is raining. And second one is the nitrogen oxide. The nitrogen oxide will react with the nitrogen dioxide in the air to produce nitrogen dioxide. And then the nitrogen dioxide will then react with the water in the air, H2 in the air, to produce nitric acid and nitrous acid. So both of these are acids, and it will also causes acid rain as it will pour down with the rain back to earth. So by reducing the fossil fuels usage, we can reduce the formation of the acid rain as the sulfuric acid and the nitric acid, nitrous acid does not form. So the second solution is to use potassium salt. So by using the potassium technology, sulfur can be removed from fuel. So potassium salt is used to induce the reactions required to remove sulfur from fuel. So normally in the desulfurization of fuel reaction, we normally use heavy metals as catalyst. So for example, platinum. But in this case, we replaced our platinum with potassium salt. This method was proven effective, and in lab alone, it was able to remove 8 parts per million to 2 parts per million of sulfur dioxide in a diesel fuel sample. So as we normally know, desulfurization process uses heavy metals such as catalysts, which for example is platinum, and they are relatively expensive. However, by using potassium salt as catalyst, it is much, much cheaper as they are more abundant on Earth. And additionally, the desulfurization process in fuel by using potassium salt is much, much more efficient because not only that we cut it more, but we can also reduce it much more. We can also reduce the content of sulfur in a larger scale as compared when using catalyst as our platinum as our catalyst. We can cut it from 8 parts per million to 2 parts per million in a diesel fuel sample. So the third solution is by using scrubbers. So scrubbers removed 80 to 95% of sulfur oxides, and only some can remove nitrogen oxides. They act as filters for factory. So in this picture, this is scrubbers. And the exhaust gas are forced through a spray of water containing lime, calcium hydroxide. The sulfur dioxide in the gas will then react to produce solid calcium sulfate. So scrubbers are like liquid filters for the gases resulting from combustion. So the exhaust gas are forced through a spray of water here. As we can see here, the gas moved from downwards to upward. So the exhaust gas will force through this spray of water containing lime, which is calcium hydroxide, CaO. And the sulfur dioxide gas in the exhaust gas, sulfur dioxide SO2, will react with the lime to produce calcium sulfate in solid form. So the calcium sulfate is then stored in a tank before being removed as sludge. So the 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 exhaust gas will not contain sulfur at all, because all of the sulfur has reacted and turned into calcium sulfate in solid form. So the only problem here is that we need to clear out the tank before it gets full, because since the sulfur is not released in the air, it will be stored in the tank, which in turn will cause another problem, which is how to get rid of the sulfur. But at least in our situation, we get to reduce acid rain. So the fourth solution is FBD, or what we call as fluidized bed combustion. So in the system known as atmospheric fluidized bed combustion, a turbulent bed of pulverized coal and limestone is suspended by an upward blast of air. So as you can see in the picture, the air moves from the downward part to the upward. Right. The combustion chamber has many boiler tubes which convert water into steam. So here, the water is converted into steam. There are many boiler outlets here. And the turbulent mixing of coal and air allows the combustion to occur at lower temperature, which reduces the formation of nitrogen oxides. Since the temperature of combustion is reduced, the formation of nitrogen oxides also will be reduced. And the limestone captures the sulfur oxide by converting them to calcium sulfate. So before the fluidized bed particle, we have in here we have lime. The same concept as before. It will capture the sulfur dioxide in the gas. So here there's lime inside here. So it will capture the sulfur dioxide in the gas and will react with them to produce calcium sulfate in solid form. And this process burns coal more efficiently by about 5%, and it removes 90% of sulfur oxides and 15 to 35% of nitrogen oxides. So the only problem for this system is how we are going to get rid of the calcium sulfate, solid calcium sulfate, as the same as before, the same as the third solution, which is the scrubber. So the last solution is using low sulfur coal. Since we use coal in huge industries, in fact in most factories, we burn coal to gain and to get energy and to do many things. So if we cannot cut off the usage of coal, we can always use low sulfur coal. So the amount of sulfur oxides emitted can be reduced by burning coal with very low percentage of sulfur. So for example, the low sulfur coal, which only contains 0 to 1% sulfur, is mined in Wyoming and Montana in the US. So as we can see in the graph here, in the table here, that some of the coal has much lower sulfur content as compared to the coal that is mined on other places. So if you can see, like South Africa has very little coal, has very little sulfur content, which is 0.6 to 0.7% only. However, the calorific value might be a little bit reduced as compared to the other coals which have more sulfur content in it. Yeah.
Assalamualaikum and hi, my name is Muhammad Ikhwan bin Muhammad Shafi'i with metric number 207602, and now I would like to explain how does acid rain happen. So acid rain happens in our daily lives mainly because of human activities. So factories, industrial sites, power plants and also vehicles release a lot of harmful chemicals into the air. So when we burn fossil fuels such as coals, the effluent gas that is being released into the air is sulfur dioxide, SO2, and it is in a very large quantity. So let's see in the photos that I have provided here, we can see that the smoke, a lot of smoke is coming out of the chambers here, and also the gases are being released by these exhausts of the vehicles. So the vehicles will release a ton of sulfur dioxide and also nitrogen oxides such as NO and also NO2. So the released gases such as SO2 and nitrogen oxides, they are lightweight and they will rise into the atmosphere and they will react with the water content and the oxygen. So after the reaction occurs, two different kinds of acids will be produced, which are sulfuric acid and also nitric acid. These two acids are highly soluble in water, and they will combine with the rainwater to fall down as acid rain. So that is how acid rain occurs. Okay, now let's discuss about the reactions that are involved in the formation of acid rain. So first of all, let's discuss about the formation of sulfuric acid. Like I said, when we burn fossil fuels, SO2 or sulfur dioxide will be released into the air. And this SO2 will react with the oxygen to produce SO3, which is sulfur trioxide. And then the sulfur trioxide will react further with the water in the air to produce H2SO4, which is the sulfuric acid, and it is in the aqueous state, which is it has already dissolved inside the rainwater. And then the second one is the formation of nitric acid. So nitric acid is the gases that are coming from the exhaust from vehicles, nitrogen oxides. Nitrogen oxides, we have two, which is NO and also NO2. So for the NO, we have nitrogen oxide will react with oxygen and it will produce NO2, nitrogen dioxide. And then the nitrogen dioxide will react with water and also oxygen to produce HNO3, which is nitric acid. So this acid is also in the aqueous state, and they both, sulfuric acid and nitric acid, will dissolve in the rainwater to fall down as acid rain.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Iman bin Abdul Basir. My metric number is 207670. So now I will explain about acid rain statistic. So from these two graphs, we can know that the increasing of sulfur oxide emission from year 1850 to up till now, 2000. So we can see the emission of sulfur dioxide increasing like so many times compared to few decades ago. So this is due to the few factors such as, like as we can see, the highest value is like from biomass fuel, other process, smelting, international shipping, petroleum combustion. So the increasing of industry will also lead to the global sulfur dioxide emission. So the sulfur dioxide emission increasing will also lead to acid rain increasing, because sulfur dioxide will react to nitric oxide to produce acid rain. So this is the graph of emission of sulfur dioxide in China. So as we can see, from the early 1900, the 1900, the China has like zero SO2 emission. So this trend keep increasing by year from 90,000 up till now as the industry keep moving forward. So as we know, China is also leading nation of industry in the world. So this also lead to the increasing of release of sulfur dioxide in China. So to conclude, acid rain which formed from sulfur dioxide and nitrogen oxide reacted with water give more dangerous to human and all types of flora and fauna. So we need to have some initiative to produce less emission of gases that can trigger acid rain. That we stated before this. So the effect could be taken when everyone took part, not only from the industry but also from other sources such as vehicle. So we also can take part by using public transport, which is more efficient and less traffic issues that can reduce acid rain. So we must cooperate to avoid acid rain issue become more significant in the future. So that's all from us. Thank you.